So today we're doing 7.2, which is theoretical and experimental probability. And the learning goal is I can develop probability models using experimental and theoretical probability. So first I want you to do the warm-up on your own. And then you are going to check your answers with mine. All right, so let's go over the answers. So the likelihood that Miss Thetford will win the lottery. While I wish that was a certain, it is an unlikely. And if I had never bought a ticket, then the answer would be impossible. So I would accept either one of these. Oops. Either one is fine. Number 2, what is the likelihood that it will snow in July? In Missouri, it has not snowed in July, so this is impossible based off of previous data. However, like I think I added the note in your guys' ed puzzle the other day. With this topic, you cannot think what ifs. So you can't go based off a scenario that you make up in your head. What ifs are out of the question during this topic and this whole chapter, really. It will not set you up for success. You have to go based off of facts. And so the fact of the matter is, in Missouri, it has never snowed in July, and so that's the fact. So based off that fact, we would say it's impossible. We can't say what if, something caused it, or what if, like we can't come up with a new scenario. So don't think what ifs, or else you will not be successful in this topic, and I don't want to see that happen. So what is the probability, how is probability used in the real world? With our warm-up the other day, we know that it's used in sports. We know that it's used with weather. And weather is spelled not with an H. There we go. And anything else that you come up with, that one's really open-ended. There's so many things that probability is used for. So as long as you had something written down there, you are totally fine. So we're going to talk about experimental probability first. And so experimental probability is the probability is based on repeated trials and experiments. And so experimental, think experiment. So this means that we actually run an experiment, collect the data, and use that to determine what could possibly happen in the future. And so the table shows the results of spinning a penny 25 times. What is the experimental probability of spinning heads? So this is like if you were to spin it and then once it's done spinning, it falls to the side and you either have heads or tails. Do not think what ifs, like if it just stayed standing up. That's not what we're considering here. It's heads or tails. And so when they did the experimental probability, they found that 6 times it landed on heads and 19 times it landed on tails. And so the probability of heads, so you always put the event in the parentheses, equals the number of times that it happened, so 6 times, over how many times they did the experiment, which was 25. So that is our answer. So I want you to give it a try with 1 and 2, and then check your answers with mine. Probability, we always write P for probability, and then in parentheses the event, so rolling a 3. So this is the number that they rolled, and this is how many times they rolled it. And so we rolled a 3 8 times, because here's the 3, and then that's how many times we rolled it. So 8 over 50, which simplifies to 4 over 25. And then the probability of rolling an odd. And so I put a little arrow above all the odd numbers on the dice or on the cube. And we rolled a 1 10 times. We rolled a 3 8 times, and we rolled a 5 11 times. So we add those up, and we get 29 over 50. So that would be our answer for the second one. So experimental is just doing an experiment, and based off of our experiment, what is the probability of it happening again? So the theoretical probability, think theory. So this is theoretical. That was supposed to be a highlighter. Theoretical, think theory. And so when all the possible outcomes are equally likely, the theoretical probability of an event is the quotient of the number of favorable outcomes and the number of possible outcomes. So it is written as a fraction, favorable on top, possible on bottom. What I want you to think here would be, this is what we expect. So this is without an experiment. This is just based off of what we know about either the cube or the coin or the dice or the spinner, whatever it is that we're using, it's what we would expect it to happen. We don't run any trials. So this is with no trials. So I would definitely star that, no trials. Up here, we have trials. We actually complete the experiment. All right, so you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So a vowel is A, E, I, O, and U. And so we have E, we have O, and we have E. So based off those blocks, I'm not actually drawing anything. I'm not actually going to choose a letter. Just based off knowing that I have 3 vowels, the probability of a vowel, just by looking at it without actually doing the experiment, I see there's 3 vowels out of 1, 2, 3, 4, 5, 6, 7 letters. And so my probability would be 3 out of 7. So I would expect that I would pick a vowel 3 times out of 7 times of choosing a letter because there are 3 vowels. So I'm not actually doing it, it's just my expectation or my theory as to what would happen. So now I want you to give this one a try and check your answers with mine. All right, so using the letters above, I see that there's only one X, and so there are still 7 letters that I could pick from. So I would assume, since I have one X out of 7 possible, that it would be 1 out of 7. So theoretical, I'm not doing any trials, and I'm going to keep drilling that in your head. All right, so now we're going to compare probabilities. And so when we compare probabilities, we're looking at the theoretical and the experimental. So the bar graph shows the results of rolling a number cube 300 times. Okay, so I know that they actually did this 300 times. That's the trial. How does the experimental probability of rolling an odd number compare with the theoretical? This is on your homework. So I want everybody to make sure that they're actually doing this one. So if I go based on theoretical, I know that 1, 3, and 5 are odd numbers. And so I'm going to write theoretical here. And so I know that the probability of choosing odd would be 3 times out of 6 total numbers on a dice, or on a cube. It's actually a die if there's only one of them. And that simplifies to 1/2. So I would assume half the time I'm going to roll an odd number. That's my assumption, that's my theory. My experimental probability is, I'm going to add all of these up, and the reason I'm actually going to make you add all of those up is because on your homework you'll have to do that. And so they won't actually tell you how many times they rolled it, they'll make you actually add up all the numbers. And so we have 48 plus 53 plus 50 plus 52 plus 49 plus 48. We get 300, which I know that they already told us, but on your homework, they're not that kind. So we know that it adds up to be 300. And now I'm going to look at only how many times I rolled an odd number. And so I'm going to add up 48 plus 50 plus 49. So now 48 plus 50 plus 49, and I get 174. And so now let's compare it. So I know 1 divided by 2, or 1/2 as a, 1 divided by 2 times, 1 divided by 2 times 100, and we get 50% of the time. We would think we are going to roll an odd number. And so now let's look, divided by 300, and then times 100, and I get 49% of the time I actually rolled an odd number. That's impressive. Look at how close these are. So because I'm only off by 1%, so it's an experiment and it's not always going to be accurate. But the more trials that you have, the closer it actually gets you to our theoretical. So our experimental, if I only actually rolled it a couple of times, I wouldn't actually know, or it wouldn't actually be close to my theoretical. But the more trials that you have, the closer it actually gets you to that theoretical probability, which is pretty cool. So now you're going to try this one on your own and then compare your answer with mine. All right, so when I found my theoretical probability of a number, which remember this means number, greater than 1, I know that on a cube, numbers greater than 1 would be 2, 3, 4, 5, and 6. So that's 5 numbers out of 6 numbers total on the number cube, and that gets me 83.3 repeating percent. My experimental probability, what I did was I took all of this information, so I ignored my 1, and I added up 53 plus 50 plus 52 plus 49 plus 48, and I got 252 divided by 300 gives me 84%. And so, like I said earlier, these two should be relatively close as long as you do enough trials. Doing only like 2 or 3 trials actually won't get you anywhere close. Now we're going to predict how many we would think would be in the bag. If we know that we have 50 marbles, you randomly draw a marble from the bag. So we're going to try to figure out, well, how many of the marbles are red when I only actually draw 30 marbles. So I'm not going to draw all 50 out. So when I did this is what I got. I'm going to do this as if I'm doing experimental probability. So we're looking at red. So I'm looking at my red, and I know, well, that's what they told me right here. Make sure we read the problem. So the probability of red is 9 out of 30 draws, because when I add all of these up, that gives me 30. And so this simplifies down to be 3/10. So that is my probability. Now I want to know, well, if there's 50 marbles in the bag, how many are actually red? And so I'm going to multiply this by 50 because there's 50 marbles, and this is just my probability. And so I get 150/10, which then when we simplify gives me 15. Now this is not an actual amount. We are just assuming based on this probability, and like this is how many times I would assume it would happen, 3 out of 10. If this continued to happen, we would expect there to be 15 marbles. It doesn't mean there's exactly, it could be like 12, 13, 16, 14, right? It could be around there, but this is just a close estimate. All right, so now you're going to start your homework on big ideas. Email me if you have any questions.